It's time for Turd Talk.
Welcome to Turd Talks. I'm your host, Musty. With me, my co-host is always Brittany.
Hi.
Good to see us. Good to see us tonight. Tonight we're going to be talking about alternate or parallel dimensions, as well as anti-gravity technology, which is all a lot like basically, like as we say, basically all conspiracy, but hearsay, as one would say. But we'll be just diving into it. We're going to pull up some footage right now, actually, before we talk. We're going to watch this one, and then we're going to get our thoughts on we'll get our thoughts on what we've seen. Which one is it here? This is the one here.
What if we told you that you temporarily live in a completely different universe than your neighbor? You might think we're crazy, but there is evidence to prove just that. Within our universe, countless variations could exist, starting right outside your front door or after your next thought. Stay tuned, because we're about to show you the scientific evidence for the existence of parallel dimensions in the multiverse. Can't we see the obvious? Many thousands of years ago, people thought the Earth was a disk and the sun and moon were points of light moving across the arc of the sky. Later, they found out that we live on a sphere and the light spots are spheres as well. Then we learned about stars, galaxies, and the vast expansion of the universe. Each time, people had to change their previously limited worldview and face new facts. Just as long, people thought the sun was absolute and would last forever. But today, we know that stars form and pass away, galaxies collide and merge, and now we must face the fact that our universe is very likely only one of many. Although we did not explicitly know of the existence of other dimensions and worlds, there is evidence of their existence all over the world and in all ages of mankind. It sounds far-fetched for rationalists when people argue at the present time with the knowledge of ancient people, or refer to the existence of natural beings like fairies and elves, or even archaeological findings that cannot be explained. Traditional natural scientists further claim that ideas of the multidimensionality of our world are nonsense or simply imaginary thinking. But if we today survey the current knowledge of many disciplines of natural science with an open mind, we must acknowledge that indications of the existence of parallel worlds, other dimensions, and the multiverse are becoming drastically.
Cheesy mushroom flatbread and an ice-cold Coke. That's my recipe for magic.
Am I muted?
Planes. Multiverses.
Denser. The reason for this are specifically the findings of quantum physics. This discipline of the smallest building blocks of the universe found out that matter splits above a certain threshold into an elusive and above all predictable substance. Quanta, which are elementary building blocks of this world, take on a wave form instead of a particle form above a certain threshold. At first, this sounds even exciting to non-scientists, but physicists know that this means that everything that was previously certain, solid, and definable blurs into a potential, and this undefined potential has even more interesting properties. In fact, scientists can no longer even determine the whereabouts of these waves. It's impossible to determine whether these waves are still in our space, whether the space dissolves at this threshold, or whether the particle waves can form several realities at the same time. The many worlds theory. The idea of parallel universes dates back to 1954 when Hugh Everett III, a student at Princeton University, developed the notion that parallel universes exist that resemble and are connected to our universe. These parallel universes branch off from our universe branches off from others, and among the universes, there can be numerous connections. If your neighbor turns his back on you in the morning after greeting you kindly, and having clearly materialized in your universe, he could be temporarily living in a completely different universe through invisible thresholds. This daring theory has many fascinating but also quite practical dimensions. In parallel universes, for example, world wars could have had different outcomes. If we take this theory seriously, it's also conceivable that species like dinosaurs still live in parallel universes. Due to the temporary overlapping of worlds and dimensions, there are occasional sightings of dinosaurs or strange creatures, such as Bigfoot. Archaeologists have found pottery showing humans with dinosaurs. In addition, objects occasionally turn up in very old rocks that were actually made in modern times. The possibility that the pyramids in Egypt were built tens of thousands or even hundreds of thousands of years ago in our era by a species that used them as power plants or interstellar communication towers could also be explained in this way. Theoretically, it would even be possible for two nearly identical variants of our Earth to occasionally merge, just as galaxies collide and merge into one entity. String theory and the many worlds theory. Many people initially doubted Everett's idea. Reality seemed too crazy, too absurd, and difficult for the human mind to grasp. But further scientific findings came to speak for these worlds. Quantum physics investigates our known world on a subatomic and thus the smallest level. Physicist Werner Heisenberg came up with the idea that we influence the behavior of quantum matter simply by observing it. Another physicist who could confirm this was Niels Bohr. Since then, science has had to acknowledge that quantum particles theoretically exist in all possible states simultaneously, and that our observation influences their behavior, forging them to choose a state at a given moment. What we experience in reality is thus dependent on our attitude, thoughts, and consciousness. Quantum physics shows us through numerous experiments that every decision and every step in this world can lead us to other realities without us noticing it in our everyday lives. Everett's approaches have long been questioned because they are incompatible with basic physical understandings of time. However, we must admit that time is still an elusive as well as describable dimension in physics. On a quantum level, time as well as space lose their meaning and can lead to infinite times and spaces. Up until now, physics has been challenged with uniting the knowledge of quantum mechanics in the microcosm with the macrocosm of the big phenomena. String theory can fill the gap between the two disciplines and thus describe our world as a whole. In string theory, it is assumed that the basic building blocks of matter are not point particles, but tiny vibrating filaments or strings. These strings exist in more than the familiar 3 dimensions of space and 1 dimension of time. If this were true, our world would be composed of at least 10 spatial dimensions. But what about the Big Bang? Everett's many worlds theory states that every time a decision is made or a measurement takes place, the universe splits into different branches. Each branch represents a possible outcome or reality. This means that there are infinitely many parallel universes in which every possible combination of events and decisions takes place. The fact that we could trace the universe back to the beginning, or at least we thought we could, long argued against this. Scientists stumbled upon evidence of a starting point, the Big Bang, by observing the inflation of the universe. Measurements of the cosmic background radiation revealed that the cosmos was a hot and dense soup shortly after its beginning. Before the actual bang, probably existed a quantum fluctuation, which can be described scientifically only to a limited extent. A sure beginning point speaks at first against the theories of the many worlds within a universe. Now, however, there was little real evidence for the Big Bang except for some model calculations. Researchers hoped for this from the new James Webb Space Telescope, but
when it comes to tough, there's no such thing as second best. No participation ribbon for serious capability.
They were disappointed. Instead of providing evidence for the Big Bang theory, James Webb found galaxies that existed at a time when they should not have at all. Since then, it's clear that something cannot be right with the assumption of the Big Bang as the beginning of our cosmos. On the other hand, proponents of string theory and the multiverse theory found evidence for the existence of further space dimensions in the inflation of the universe. Some of these dimensions might exist purely computationally rolled up within ours. These dimensions are so tiny that we cannot perceive them directly. You can imagine a thin tube consisting of only one line. Upon closer inspection, we see that the line is actually not straight, but has curved into an additional tiny dimension. Although the curled up dimensions are small and hidden, other worlds may be hidden within them. The way the strings oscillate and propagate in the coiled dimensions is even supposedly recognizable from certain properties of observable matter in our universe. Nevertheless, the theories have not yet been proven. Some researchers even found indications in the Big Bang calculations that not only one, but 3 or possibly even infinitely many universes were formed at the starting point. Some of these models foresee that the other worlds are extremely different from ours. If they are tiny, or within them completely different physical regularities apply, we could never travel to them and presumably also not describe them. Other theories envisage that we are connected to and even live in a multitude of other dimensions. In the multiverse, all these possibilities exist together. There are worlds which are similar to ours, in innumerable variants, as well as universes which are completely different. A dimension inside our Earth? In Antarctica, scientists measured neutrino particle streams from space. NASA's ANITA Antarctic Impulsive Transient Antenna used a giant balloon to measure neutrino swarms from space high in the cold, dry air of Antarctica. Suddenly, the antennas registered a stream of low-energy particles, or neutrinos, coming directly from the center of the Earth. Neutrinos can only penetrate thin forms of matter, never the entire globe. This means that high-energy particles can actually only be detected when they hit the Earth from space. The measurement suggested the existence of a parallel universe whose intersection is somewhere inside the Earth. The particle stream even allowed conclusions to be drawn that the tau neutrinos had traveled backward in time. In the universe of the origin of particles, time goes therefore backwards, or the time axis of this cosmos is mirrored against ours. Black holes, white holes. Researchers often stick with model calculations or simulations in order to elicit the universe its secrets due to the lack of direct observation possibilities. For example, Albert Einstein mathematically predicted the existence of black holes long before the first real black hole was discovered. Then, just as hypothetically, researchers concluded that black giants in other dimensions or universes might have counterparts in the shape of white holes. Model calculations reveal that white holes repel matter and light, while black holes trap matter and light. White holes hypothetically appear where ideas of time reversal in other dimensions are invoked to explain previously unexplainable phenomena in our cosmos. Our universe has truly an interesting characteristic which can be seen as a further hint for multidimensionality. Wherever an explanation appears, many new questions and variants of the cosmos arise. According to quantum physics, different expectations lead to different results and worldviews. According to quantum mechanics, a physicist can turn at one point and prove these theses in his reality by real observations. He's then rewarded with the Nobel Prize and has a stellar career. In another universe, however, the proof remains missing, or other scientists are right and clear the Nobel Prize for themselves. Do you think this evidence is meaningful? And can you imagine?
Jackie Bird, good to see you. You still here, Brett?
Yeah, I'm here.
Yeah,
Sorry.
okay, no problem. So yeah, the idea of this multiverse or this, parallel dimensions within our own universe, I guess it would be, kind kind of like, I mean, in a way, it would make sense in a theory, like yin and yang almost kind of thing. Um, you know, you can't have light without dark. You can't have, um, you know, one
So
without the
did
other.
it say the white
The white holes.
light it repels?
It repels. So
So
basically what it would do is be spitting matter out, be spitting out atoms and matter into the universe. And what a black hole does is sucks everything in. So it's like would be like an opposite of a black hole.
my brain,
It is a brain. It definitely
my
takes a
brain
lot
is
to
like,
comprehend. And like in my best analogy of it is almost like theoretically it's almost like a machine type of thing, like, you know, um in a sense, like you can't be, it's like a recycling process sort of thing, like you gotta put new matter in, take new old matter out, and recycle it. So it could be um it's just it is really hard to comprehend. It is very hard to comprehend.
but I will say this.
Hmm.
I will say that. Sorry about my kid in the background.
Oh, that's fine.
The one thing I did learn by
Mhm.
trying to research this stuff is sorry. I'll tell
Sure.
you to be quiet.
Yeah.
The one thing I learned when I was trying to research and comprehend, and I know it doesn't even relate to this, but I realized, is this how people feel when I start talking about the Bible? You know, like they're looking at me like I'm not getting it, because it's how I felt when I was like trying to
Mm.
look up stuff. I'm like, I don't.
Well, I'm sure with some people it may be that way, for sure. It's hard to say. I mean, it's hard to.
So gravity is what goes up must come down,
Yes, gravity. Yeah,
and
basically.
anti-gravity is going to be what? The
Well,
opposite, like it doesn't come down.
with the anti-gravity, it would be anti-gravity technology would basically be some kind of technology that would work against the force of gravity. So, in theoretically, you would be able to move through gravity, um, with whatever like technology would allow you to propel through gravity. It's based. Think of it like a magnet. Like if you have two magnets and you're trying to put them together, they're forcing each other apart. Think of what like anti-gravity technology would basically be whatever kind of force would be the opposite attraction of gravity.
Like what happens when you're in space? That's the
Well,
opposite.
when
Like
you're in
in
space, there's
the
zero gravity.
astronauts.
There's zero gravity in space.
But
There's no
so zero
gravity at all.
gravity and anti-gravity is completely different.
It is completely different. Yes.
Oh,
Yes. Like, yeah, like I say, think of it like this is very simple, but if you have a tap and you're running it like lukewarm, right? As opposed to it's not fully hot, it's not fully cold. It's running lukewarm because the hot and the cold are running against each other. So the force of gravity is what keeps everything, as far as like, you know, the ground, like the everything that's not attached to the ground, from not just floating off into space, and all our oxygen and whatnot in our atmosphere. But anyway, um, the force of gravity, there would basically, the theory would impose that there would be a force that would counter it. So it would be working opposite of gravity. So um, instead of a force that's pushing down on the Earth, it'd be a force that's pulling up at the same frequency or the same strength, I guess. It's hard to say exactly what that. terminology is. But it would impose that it would have to be some kind of knowledge that we don't have to figure something like that out.
So what does all that have to do with? Because I don't believe in that, but
Hmm.
they kept talking about the Big Bang Theory.
So the Big Bang Theory is the theory that that's how the universe started, with a bang, and then everything was like spewed out and then grown. Like basically, that the universe, ever since the Big Bang, has grown outward.
But what do they say the bang is?
Like basically, it's like a release of energy, or we could look one up here on the Big Bang Theory, real quick
Because
for
they
us.
kept mentioning it a few times.
Yes, we can look up the Big Bang for
Because
you.
here's mine about the whole Big Bang Theory and all that stuff.
Mm-hmm.
In Genesis 1:1, it says, "In the beginning, God created the heavens and the earth." And I tell people, the beginning is time, the heavens is space, and earth is matter. Makes sense to me. But other than that, I've never really thought about. I mean, I find it interesting, like the Bermuda Triangle.
Mm-hmm.
Like, would that be something like that, or like
Well,
you get
that
sucked into something, or is that something different?
Well, you could with that's the thing with the theory. You could definitely say that in theory there could be a spot that is like he was saying, a spot that is somewhat of a gateway, or like a void into another dimension or reality. So if that was the case, let's say theoretically, if you were to fly through the Bermuda Triangle, you could theoretically end up in another dimension on the other side. What that dimension looks like, or how the laws of physics work in that dimension, aren't exactly too sure. They don't necessarily have to be the same as ours.
Has there been people that came back?
Not to my knowledge. Not to my knowledge. Not that I know of. No. I have not found any information on that. Okay. No, we want the actual Big Bang Theory. Give me the. Here we go.
The ancient Egyptians understood that they could use sound to reduce their weight and the gravitational effect.
Through
There it is.
archaeoacoustic research, we are now close.
How was our universe born? And if this seems hard to answer, then how about this? What was before our universe? While scientists are looking for the answer to the most difficult question in history, let's find out what they've come up with so far. In the 20th century, we've shed the light on this mystery, all thanks to this man, Edwin Hubble. One day on Mount Wilson in Southern California, he aimed his telescope at the sky and found out that these random clouds of gas flying everywhere are actually other galaxies, and there are a lot of them. And also, he learned something else, something that changed the world forever. They're moving. So what, you may ask? Well, it meant one very important thing. The universe is expanding, and if it's expanding, then it probably had a beginning somewhere, right? Now, all we have to do is run time backwards and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory, and here it is. Nothing has ever been anywhere because neither when nor where existed. Do you get it? But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects into the world, stars. And all this happened just some 12 to 14 billion years ago. All right, now we know how our universe was created, but what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. Let's hang a balloon filled with paint to the ceiling and lay a white canvas on the floor. If we drop the balloon down, it will burst and we'll see absolute chaos on the canvas. A bunch of spots scattered everywhere randomly. Neither is like the other. But that's not really what the universe looked like. Instead of throwing a colored ball from the ceiling, let's draw a small red dot on the canvas. Now, let's expand it a little more, and capture this all on frame-by-frame shooting. We'll see a circle gradually growing in all directions. That's the reality. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Guth's theory was a success, and now most scientists rely on it. For most of them, this idea of the birth of the universe is quite enough. For most, but not for all.
Dinner looks a little different with a new family member.
Martin Bojewald is a German professor of physics, and, in his opinion, the universe was born quite differently. Remember when we talked about cosmic singularity? The state of the universe in which it was small, infinitely dense, and super hot. According to Martin's theory, the singularity couldn't just appear out of nowhere. This is nonsense. But then, where did it come from? Let's look at a pendulum on an old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time, quantum time doesn't work that way. It's more like the second hand of a clock. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. See what I'm getting at? Let's go back to balloons again. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then guess what? The Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Bojewald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. Unfortunately, we don't have enough knowledge to find all the evidence for it, so for now, all this is just a hypothesis. But some people come up with even stranger ideas. Scientists promote such unusual theories that no one could even think of. Neil Turok, a South African physicist, and his colleague, Paul Steinhardt, an American theoretical physicist, look for answers far beyond our universe. They say that yes, our universe isn't the first one. There have been and will be an infinite number of them. And not only will there be endless Big Bangs, our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. This sounds incredible and frightening at the same time. But how does it work? According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on. Like pieces of fabric on a rope, these parallel universes are located near each other. Each one has a neighbor. We're not the exception. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until one day they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. But when they disappear, the brains collide again. And this will lead to the birth of a new universe. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Of course, everything described here is a great simplification. When you hear that our world is some piece of fabric on a rope, it sounds like complete nonsense. But this idea is based on string theory and M theory, two giants of quantum mechanics. If they turn out to be true, they could explain almost everything in our universe. Creating a theory is an incredibly huge process. Turok and Steinhardt made a huge amount of calculations and swept away many, many non-working theories. Also, to work this out, they have to overcome the limits of the human mind and think in 11 dimensions at once. Unfortunately, this crazy and elegant idea was laughed at. Turok and Steinhardt say that scientists are regular people, just like everyone else. They're also afraid of change and the unknown. And it's really scary to question everything we once believed in. Many years ago, people didn't believe that the Earth was round. Then they were outraged by the Big Bang Theory. We can't make discoveries without struggle and fear. That's why Turok and Steinhardt don't plan to give up so easily. After all, the evidence that we have now only says that each of the three theories is equally possible. So which answer is correct? We may never know, at least not at this stage of human development. Unfortunately, as long as we have no evidence, we can only theorize. But maybe one day we'll find something that will open our eyes once and for all. Maybe one day we'll solve the mystery of how our universe came to be.
Yeah, so that's the Big Bang, string theory.
The only thing I gotta say is let's go, Brandon. Because I heard inflation way too much in the video.
Inflation. But yeah.
Like, hold on, wait a minute. We don't like that word.
No, we don't like that part. So, like I say, this is all.
They said there was another force that had to push it, right?
Yeah, so it'd be basically saying that everything within our universe is like a sphere. And it's like floating out there in empty space or negative space, whatever you want to call it, and there's multiple universes, or well, we're in a galaxy, but that's in a universe. So anyway, multiple universes within this space. So what we did was collide with another one, and it would basically be, like I said, like a magnet type thing. It's inevitable that we're going to collide with each other, but because of it, because of the collision, we're going to force each other away from each other. But at the point of collision is going to be the Big Bang.
Why is it, let me see how to say this. Because I'm trying, you know what I'm saying? I'm trying to comprehend, but I still have my beliefs. But I believe they go hand in hand. Does that make sense?
Mm-hmm.
So maybe that force is God, because he's outside of the universe. He's outside of time. Like, you know what I'm saying? To make
I know what
this
you're saying.
somewhat make sense.
But the thing
Something
is,
had to do something, right?
and the thing is, the way that most people might comprehend God or heaven in a way, it might be like it could be very like completely incomprehensible. So to be in heaven could be to be a different
Dimension.
in a different dimension, yeah. And
You
in
could
that,
get the first heaven, the second heaven, the third heaven.
yeah, like I
There are
definitely,
other dimensions.
and like I said before, and like we were talking before, I believe in reincarnation, and then when I said that, like that in a way could make sense, whereas like you or let me sorry like stories from like past lives and stuff like that. I know that I personally myself, and I know there's stories of others that told talked about their past life when they were really young, like under the age of 5 or 7 or so like that. I can't remember how old I was, but my grandparents would tell me vivid stories. That I would tell them vivid stories about the war and stuff like this. But if it was a parallel dimension, which was the same but different, the war would exist as well. And if I was, you know what I mean, could have been lived in a parallel dimension. Who's to say, you know? And others could experience that as well.
I'm not. I know this sounds crazy. You know, I believe in angels and demons and all that. And that is in another dimension, the spiritual realm.
Right.
But I promise you, in my house, no matter how many times I pray, bless my house, I hear a conversation in music. Bro, don't put me in a padded room, bro. I better back up off me. I hear some. It's like it's in a different dimension. Is the only thing you can like. And like I told you before, my husband is a skeptic, and even he's like, "Yeah, I've heard it."
Okay. Yeah.
You know what I'm saying? Like,
yeah. I mean, like, it very well could be. It might could be. Like, theoretically, it could be.
well, I mean, I'm leaning towards that, and instead of being crazy,
yeah. Well, exactly.
He said, "I'm calling right now." No, please don't. So
yeah.
I also seen where there was like what 11 dimensions supposedly. Didn't really get too much into it, but
yeah. There's supposedly, I think it's 10 or 11. You have to have at least 10 dimensions. I did have one here that I had. It's not a video or anything, but it's just, I'll read it. Let me pull it up on screen here. A universe of 10 dimensions. When someone mentions different dimensions, we tend to think of things like parallel universes, alternate realities that exist parallel to our own, but where things work are or happen differently. However, the reality of dimensions is how they play a role in the ordering of the universe, of our universe, is really quite different. This from popular characterization. So yeah, I will just put it up on screen here. I'm not going to read it all, but we have different dimensions. First dimension, as already noted, is give this length.
yeah, read that part to break it. No, go back.
Yeah.
To break it down.
The first dimension, is basically like take a piece of paper, draw a line, and you look at that line. That's one dimensional. An object is a straight line that exists only in terms of length and has no other discernible qualities. Added to a second dimension, the y-axis, a height, and you have an object that is two-dimensional. shape, like a square. So a square would be a two-dimensional shape. Third dimension involves depth and gives objects a sense of area and cross-section. The perfect example of this is a cube, which exists in 3 dimensions and has a length, width, depth, and height, or hence volume. Beyond this 3 lie the 7 dimensions, which are not immediately apparent to us, but which can still be perceived as having a direct effect on the universe and reality as we know it. Scientists believe that the 4th dimension is time, which governs the property of all known matter at any given point along the 3 other dimensions. Knowing of any object position in time is essential to plotting its position in the universe. The other dimensions are where the deeper possibilities come into play, and explaining their interaction with the others is where the things get particularly tricky for theorists. All right, so yeah, this is talking about things theory, or string theory, superstring theory, 5th and 6th dimensions. Just read all that if we want. These are all just theories, right?
Right. The 7th one, it says you have access to possible worlds.
So when you think about it, the aliens as interdimensional, what was it? Extraterrestrial.
Canadian just showing.
Yeah. Extraterrestrial. Extraterrestrial, that's what I was trying to say. But anyway, that means they're not of this Earth, so we're trying to think that somewhere else in is our galaxy or universe story, there's another planet or something that can hold life. But it could be, they could be interdimensional beings. So therefore, like I said, if they were able to move through the dimensions, they could potentially move into our dimension for a brief period of time. And that could be explained why a lot of the times, it's like, where do they go? You think they'd be able to trace them to somewhat of a point of origin, out of our atmosphere, not just our atmosphere, but
No, I get exactly what you're saying.
Yeah, out of our galaxy, right? So all accounts of any UFO sightings or anything like that, it's all they just disappear. They're just there and then they're gone. So it makes you wonder.
I'm just going to have a conversation with God. It's going to take eternity to... I feel like my head's already about to explode.
And the thing is if like you say, if it is a dimensional thing, and maybe you move through the dimensions, or you can move through the dimensions with a higher comprehension of your what's the word I'm looking for? Consciousness. Then maybe as you progress, it's different. You know what I mean? There's different maybe what you're supposed to do to be a good person in this dimension. Maybe in a different dimension, you're supposed to live a different way. Do you know what I'm saying?
Right.
And you're supposed, but whatever it is, it's all for a reason. is what I'm trying to say. So, maybe the heavens is a way to ascend to a different dimension.
Wait, I want to say something. Jackie said something
Mm-hmm.
in the chat. He said Jesus did say he still had to go take care of his flock before he ascended. Maybe he went to other planets or dimensions. See, I'm with you, Jackie. Like most Christians are like, oh no, no, no. But he rose when he died on the cross. He went to Hades, and then he rose from the dead. What was it like? Wasn't it 40 days, Jackie? For 40 days, nobody knew where he went, but he didn't go to heaven yet.
Mm-hmm.
So was he possibly in these other dimensions, other universes, other galaxies?
Mm-hmm.
You see what I'm saying? Like, I don't
Right.
knock none of that out.
Right.
I'm never going to go against the word of God, but not everything's in this book.
Right. And sorry, I'm not too familiar, but I'll ask you because I'm not sure if it is. But purgatory, is that in the Bible as well?
That's a Catholic thing.
It's a Catholic thing? Okay, so that's totally different then. Because I'm not too sure about how the whole idea of that works. But if that is the case or whatever, like let's just, for argument's sake, that could be maybe a different dimension as well.
Right.
Right. Because some people. Sorry, go ahead.
Sorry. I'm gonna keep doing that to you. Sorry.
Sure.
I played with 3 Canadians yesterday, and they were like, sorry. And dude's name was Terry, and they were like, Terry. And now I can't get it out of my head. Now I can't even remember what I was going to say. Go ahead, Daggum it. Sorry. Sorry. Can't stop. No, the purgatory. Like in the Bible, before Jesus, Mom help me, Jackie help me in the chat. When people died, where did they go? Well, they had something called Abraham's bosom, and then there was Hades.
Okay.
So those have to be other dimensions. They have to be something, because it's not one dimensional. Like, you know what I'm saying? It's not here on this earth. They wasn't here. They were waiting somewhere. When he went to Hades, where is that? That some people, like, it's hard to try to comprehend, but it's a place. It's somewhere.
Well, I mean, it could be in a sense that maybe, as I say, if there's dimensions, don't think of it as we're the starting point of the dimensions and they move upward from us or what have you. We could be in a different, like let's just throw this out there. A cartoon, for instance, that we draw, right? That's a two-dimensional. That's a two-dimensional like show or whatever, or comic book, whatever. But we made that, but that still exists. It's not alive, but it's still made up of atoms that we put lead on paper and drew that, and now it's a thing. So like we were born, but it was all actions that led us to be the machine that we are for our consciousness. So who's to say that we don't descend? Maybe if we don't live by our certain morals or certain, how we're supposed to live as a good person, maybe we, instead of ascending in the dimensions, maybe we move down, and instead of being born into life in a two-dimensional, I exist as maybe a cartoon on a piece of paper, and I don't have thoughts. I don't have anything, but what my atoms are right now are recycled into just paper, and I get to like experience that. It's kind of hard to comprehend,
You could have said anything, brother. and you chose a piece of paper.
Well, I mean, it
To
could be
experience
anything.
life as a piece of paper.
Well, basically, yeah. Or any kind of object. It could be anything, you know?
If I was to be a piece of paper, somebody better make me an airplane. Because I ain't just going to lay on a disc. Like, let me be the airplane. No, clearly there's something. There's like when I'm preaching to people or witnessing to people, these are a lot of the questions, you know, like, but like Jackie said, and Mom said, it's your faith, but they do go hand in hand. There's some people that don't want to talk about science at all, and you can't. Science, I believe God created science. Like everything is perfectly, like our fingerprints and the galaxies. What is it, James Webb Telescope? Have you seen any of them images yet?
No.
Oh my gosh. Amazing. Like somebody had to create that. And it's someone that's outside of different dimensions. Like I was reading that thing you put up, the 10th dimension was talking about like it would be outside of mortals. So I could see that, you know?
Yeah.
In the beginning, God created the heavens. That's all these universes and dimensions. But our brain can't really comprehend that.
No, well, exactly. And if you think
We
of
would
it,
explode.
Well, you think of it this way, you in your brain, you can just come up with the most outlandish, wild, like monsters or creatures, or like people who have made horror films or such that have come up with these just, you know, wouldn't exist, crazy, you know, aliens or different species and different things. That has to come from somewhere. Like we create that when we come up with those ideas, but now it's a living thing. So it's living within our brain. We can think about it, and did you get what I'm saying there? And if you look at the universe as maybe like a brain or an entity of sorts type of thing, maybe it's all just being created as like how we create thoughts. And maybe as such the creator is God, or you know what I'm trying to say?
Yeah, I get what you're saying, because the Bible says that us humans were created in their image. That's your consciousness. Because like I said, even people that don't believe still have a moral compass.
Right.
Where did that come from?
Right.
It had to come from someone that's, you know, outside of this universe. It had to come somewhere.
Right.
I don't.
So like
or
yes.
like people, the evolution thing. We came from monkeys. Then why are there still monkeys? Why is it Coco the gorilla?
And I mean,
zoo,
right. And even
all
with
of a sudden a person.
Yeah, and like to an extreme. So like look at it like evolution as ascending as well. So we, for whatever reason, we ascended to the knowledge of, like you said, having that moral compass and whatnot. But even like the moral compass thing is even with animals as well. Like there'll be certain animals that have motherly instincts and territorial instincts and such. That comes from that just overall, like you say, moral compass of knowing what's right from wrong, danger from, like, you know.
No, you made me think. Y'all know how my brain works. You made me think you were like animals that have a motherly instinct. I instantly thought of the praying mantis.
Well, no, not in all senses. Like,
No,
They
but
don't
that's
all,
what I'm
but
saying. But like, I get what you're saying. Like I think about a dog. Like a dog is man's best friend type of thing.
mhm.
Like they know. Like I mean, think about Lassie. Come on, Lassie.
Yeah,
These animals have emotions and they know it's like they know right from wrong. But I'm just saying, like, I'm just trying to have conversations and talk about stuff because things are going to get really wild here soon with this whole alien stuff.
yeah,
And I don't know what information is going to be out. They're already deleting stuff. They're already taking down. Like, remember I told you about that lady in the 90s? I think it was
yeah.
1994.
Mhm.
The doctor, I can't remember her name. I want to say like Kang Lee or
Okay,
Ling Lee but she supposedly had proof of the anti-gravity
right.
thing being,
We'll
that it not being a theory, and she's disappeared, and so is all
right,
her work.
right. So we'll pull up some anti-gravity here for a minute here.
Oh, I like that, Jackie. Yeah, the DNA markers. Jackie says, like DNA markers. Why is it so perfect in its organization? If there was evolution, there would be some unorganized part if evolution was true, but it's not. Now, do I believe in evolution, like how they put it? No. Do I believe things can evolve? Yes. Do you see what I'm saying? There's a difference there.
I get what you're saying there. Right now we got a little bit of the anti-gravity here up on stream. I don't know if it's gonna play for us or we got to maybe we have to YouTube it.
One of the most obvious observations about gravity is the simple aphorism, what goes up must come down. It's just how gravity works. It pulls things downwards. But then there's this thing some people talk about called anti-gravity. Is it real? Well, no, or at least probably not. But respected scientists are looking into it, which means that we need to know more. At CERN are investigating the possibility of real anti-gravity using antimatter. And yeah, got to admit, that sounds totally cool. I'll talk about this very real science in a moment, but first I think it would be fun to spend a little more time on the silly stuff. So let's talk about some of the ideas you can easily find if you surf the internet. The most common is when people imagine that some sort of electrical current will overcome gravity. They go by names like gravitoelectrics or sometimes electrogravitics, just to change it up. Then there is another term you'll find called gravitomagnetics. Now, first of all, these are all made-up terms. They all sound very sciencey and all, but they're not. And furthermore, different people will use the same term for different phenomena. So that should tell you something about how seriously you should take them. But here are some specific ideas. In the 1990s, a researcher claimed that rotating superconducting disks would shield 2% of gravity. Another person has claimed that parallel plate capacitors can shield gravity. Then there is the claim that flowing dense fluids in pipes wrapped around a torus will create a repulsive gravitational field. While you'll even find people who claim to have made machines using these principles, none of these ideas have ever been replicated by other researchers. Scientific claims that haven't been replicated should make you go, And of course, no discussion of anti-gravity would be complete without touching on the UFO enthusiast community. Some members claim that the US government is in possession of a crashed UFO or two. The most famous is the supposed crash of a flying saucer at Roswell, which the story says was transferred to Hangar 18 at Wright-Patterson Air Force Base. And who can forget the claims that at a facility called S4, not far from the famed Area 51, that the US has not one, but 7 captured flying saucers, which the government has reverse engineered. Those would all be amazing if they were true, but they're not. Now, I know that some of you will disagree with me on topics of UFOs and captured flying saucers and anti-gravity technology, and others will claim that I'm lying to hide the truth. But to quote Carl Sagan, extraordinary claims require extraordinary evidence. So I say, prove it, and make it worth your while. If you have evidence of a true anti-gravity device, there's a prize waiting you worth €1 million, which is over $1 million. It's called the Godia Award, and I put a link to the award in the video description if you believe you have developed an anti-gravity device. We live in a world in which it is possible to make outlandish claims that then spread like wildfire across the internet. But that doesn't make them true, no more than the one I heard the other day, which was that the Fermilab's famous Dr. Don knew too much, so he was neutral in physics theories. So I'd be thrilled if you want to study the gravitational behavior of antimatter, that you need to shield your equipment incredibly well from stray electromagnetic fields, or it will screw up your experiment. So, researchers at CERN get around that by combining an antiproton with an anti-electron, making anti-hydrogen, which is electrically neutral. It's a clever solution that sounds easy, but is pretty tricky. And the various different experimental groups at CERN do it in different ways. Then the different experiments either launch their anti-hydrogen upward or sideward, or just release it from rest and look to see what happens. Does antimatter fall down or up? There are several experiments at CERN vying to be the first to make this measurement, with names like Alpha G, G-bar, and Aegis. The competition is certainly intense. So, what's the answer? The short answer is that we don't know just yet, but we should know soon. I visited the Alpha experiment a few years ago, and they were on the cusp of having the answer, but then the CERN accelerator complex shut down for upgrades, and the COVID situation caused additional delay. That makes me sad because I really want to know the answer. So what do most scientists think will happen? Pretty universally, we all think that antimatter will fall down, just like matter does. The reason is that for both Newtonian gravity and general relativity, gravitational force depends on the mass of an object, and we've measured the mass of antimatter subatomic particles, and it's exactly the same as their corresponding matter particles. The mass of an antiproton is the same as the mass of a proton. We've measured that. But, and this is a big but, we've measured the inertial mass of antimatter particles, not their gravitational mass. Inertial mass is a measure of how particles resist change in motion, while gravitational mass is a measure of how they are affected by gravity. I made an entire video on the difference, which you definitely should watch. I put a link to that other video in the description for this video. For matter, inertial and gravitational mass are the same. In fact, that's a key assumption of Einstein's theory of general relativity. It even has a name. It's called the equivalence principle. But the simple fact is that we've not measured the gravitational mass of antimatter. Maybe the equivalence principle doesn't apply for antimatter. Maybe for antimatter, gravitational mass is the negative of inertial mass. If so, that would be a very big deal. And it is indeed possible that antimatter falls up. We're going to have to wait for the experimental results to be announced. Don't expect anything for many months, probably a year. But it's coming, and the measurement is going to be super epic. This is real science. On the other hand, bringing this back to the scientifically irresponsible side of the anti-gravity conversation, even if the CERN experiments find that antimatter falls up, that doesn't help us with making gravity shields in our house, nor does it really explain the claims of the UFO community. Antimatter is exceedingly dangerous and outrageously hard to make, and that would still be true even with very advanced technology. And it's also still true that magnets, superconductors, capacitors, and spinning toroids don't cancel gravity. Sorry, guys. But keep an eye out for the CERN results. It's going to be awesome. Hi, guys. If you like the video, please be sure to subscribe to the channel and share on social media. And while you're
I was muted. So what I got out of that, Britt, sorry, just kind of like I was saying earlier, you need to have a force that's working against the force of gravity. So if the force of gravity for matter is, like he said, pulling downward, and it very well could be that the force of the antimatter could be pulling upward. And if that's the case, then you could travel, let's say, in a different dimension. That's how their matter is antimatter. Like, how do we know for certain? You know, like, I don't know too much about
think about it, since
antimatter.
we're going to be raptured. That means caught up in the sky. Would that be antimatter? Because we don't come back down?
I mean, I don't know. Like I say, I don't know much about the whole subject of antimatter. Seems kind of a little hard to comprehend, like you say, a lot of this. But as far as what like they would claim would be a force that, like say, would work against, and like they said, he was saying the different theories with have to do with magnetics and stuff like that. Because, like you said, it works on the same principles how two magnets would oppositely attract from each other. So if you try to push two magnets together, they would simply want to push apart from each other. Right. So, but with enough force, those magnets would have no choice but to collide with each other, and that goes to the whole theory of the Big Bang. Right. Two objects that we had no choice but to collide, and from that there was the Big Bang.
When I was looking at this research, this is off topic. Mm-hmm. I just want to know if you've heard anything about it. Have you heard about the sun breaking off recently?
Breaking off? What do you mean?
I was looking up this stuff before we came on, and it was like so much stuff's going on and changing, and the universe and galaxies and this, and a piece of the sun has broken off. And I was like, what?
Piece of the sun broke off. I didn't hear anything. I've heard of solar flares.
I didn't hear
before, but I've never heard of that.
Okay, help me to understand this.
Okay.
What is a light year?
A light year?
It's like my brain don't comprehend. TV said it's like, that star is 7 light years away. I was like, I don't understand.
So
he's like, we're seeing it 7 years later.
I think something along those lines. I'm not 100% sure with that, but I know that when we see stars, it's like when we get to them, they're wherever they're at, they're already gone. And the only reason we see our sun is because it's our star. It's in our solar. It's in our solar system. When we see other stars, they're already burning up. By the time the light gets to us.
Would that help explain dimensions?
I mean, as well, like time works differently as you move. As well, like if you were to go theoretically out into the universe, and you were to travel at higher speeds, which we can't do obviously because it just doesn't apply to the laws of physics and our body. Our bodies would simply, once we get to a certain speed, we would basically just turn to mush on the floor because the force of gravity would pull us downwards, or different. Sure exactly how it would work in zero gravity, but there's no propulsion system that you can move through zero gravity because you have nothing to push against. You're pushing against gravity when you're leaving the atmosphere. That's why they need such big rockets and so much fuel, because it takes so much to get out there. But when you're in space, you need, I mean, it's just not enough. There's nothing to push against. So you'd need some kind of reusable, or like some kind of propulsion that would allow you to move on like a...
Is that why in the movies, like all the astronauts, when they got to go outside their shuttle and fix something, their biggest fear is getting propelled off? Like, you're not coming back.
Well, no, you're not going to come back because, like you say, you're moving. Especially if that's moving at a certain speed, and then that knocks you into space, then you're moving at that speed away from the craft or whatever, the spaceship.
Could you imagine how terrifying that would be?
Something like that.
Imagine being an astronaut outside trying to fix something, and your cord that's supposed to keep you safely harnessed breaks, and you're looking at this thing with your helmet, with whatever oxygen you have left in your suit, and you are propelled into space. You're not going to die immediately because you have oxygen in your...
Right. No, exactly. You're gonna have to...
That would be terrifying.
Yeah, you'd live till the point that your space, you run out of oxygen or whatnot, then you'd freeze. But no, it would be really bad. Really, really bad for sure. But as far as the light year, I'm not sure exactly what a light year is, but the speed of light, it's basically... Hey, Ghost, good to see you. The speed, or what light? The speed of light, to travel that fast, it would, by the time we would get to where we were going, time would, once you're traveling at the speed of the light, time doesn't really exist anymore. You're traveling like through time. So theoretically, you could travel back or forth in time. Light travels through time, basically. Like, time exists within light. So if we were to travel at the speed of light, theoretically, where our family and everybody else that are living here on the planet, they'd be living 1,000 years could go by, 1 billion years could go by, and it could be like we're there and it took maybe a month, but back here, years and years and decades and centuries went by because we're living under the laws of time. So we can't move that fast. We'll never be able to move that fast. But light moves that fast. And light, what is light made up of? Particles and atoms, just the same as what we are.
It got me to say, dying in space is like dying in water. I would agree, because like my husband told me last night, like a lot of people think that NASA has this machine that they practice in to see what it's going to be like in space. Yeah, he's there. It's an anti-gravity room, dude. But he says actually NASA usually practices in the ocean just to simulate what it's going to be like in space.
Right, yeah. Yeah, that's what they do, yeah. Because it's as close to zero gravity as you can get on Earth.
And it's so weird.
It's just the density of the water allows you to that's how you basically float, right? Because what's inside of our lungs is oxygen,
Mhm.
right? So we work as like a balloon. If you put a balloon of water, the water's so dense, but air isn't dense, right?
Right.
So we can't. We're not. It's not quite zero gravity. That's why we sink. You know, you can't. You have to tread
Right.
water. You can't just float. But and then when you throw all the gear on and stuff like that, then you weigh more. You're obviously gonna go against the force as well.
Put a reverse jury.
But it's as close to zero gravity. I'm not sure exactly what the number is on like the force of gravity, like, you know. But the same as like if you throw a rock off the top of the Empire State Building, it's gonna fall, and as it falls, it's gonna accelerate because of the force of gravity that's pulling against the rock. But if you throw if you drop a rock off a yacht and then it lands in the water, it's only gonna like gain the force that it takes to land in the water. Then it's gonna make the splash. The initial splash is going to take away from some of the force that's already gained, the velocity, and then it'll move in a downward, you know, but it's only going to move it's not going to move the same speed if you dropped right at the top of the water. If you dropped it in the largest point of the ocean, the Marianas Trench, and then you dropped one off the highest point of the Mount Everest, the Mount Everest one's going to travel with more velocity and speed than the one in the water will.
Yeah, so like basically jumping off the roof of a pontoon boat into water versus jumping off a bridge, you speed up, so that's why like you hit water. Isn't it like hitting concrete?
Yeah, once you get to a certain speed,
It's because you've sped up, right?
Right. And like I said, what you'd be doing is once you get to a certain speed as well, like there's the different speeds, like G-force. Like say you're in a Corvette or a fast car, and you get going really fast. You get that feeling like you're stuck back in your seat. That's what they call G-force. Or like when you're taking off in an airplane, you reach a certain speed, and it's the force of gravity pulling against your body, pulling you into the seat. So once you get to a certain speed past the G-force, like way past, you'll be, like I said, you'll be pulled down. You're basically, everything would be just stuck to the ground. Like you'd be mush on the ground because the speed, the force of it would be too much. So that's why we could never travel at the speed of light. We can never exist on that, exist in that dimension of speed. Like we just couldn't do that.
Well, think about when they, you know, people are trying to be an astronaut as their profession, and they put them in the flight simulator. A lot of them pass out.
Right. What I found interesting.
Have you ever watched that? That's crazy. Like,
yes, it is.
Like,
it is. But as well, what I found interesting too is when you're moving at faster speeds, time moves differently at different speeds. So if,
what do you mean?
So for instance, if you and I are like, if you had a child and right at birth you put a watch on the child, and then in 20 years, like, it had a sufficient battery to live, and in 20 years you check those watches, they would be different times because you would travel through life at different speeds throughout your life, and time would change with it. just slightly, just slightly, maybe by a microsecond here and there. But you know, like I said, the G-force, when you're moving, say you're running real fast, or you're bicycling real fast, or on a motorcycle or Corvette, like I said, like the top's down, you feel the force of the wind, like you're cutting through wind, right? When you're walking, you can't feel nothing, like then the air's thin and you don't feel it. But when you're driving, like real fast like that, and you stick your hand out the
Right.
window, you feel like your arm's in like a cloud or something. Like there's something there. That's the G-force pulling against your pulling against you. So when you're traveling at faster speeds, the time moves differently as when you're standing still.
I get it. I didn't at first.
So, like I said, light travels at the fastest speed possible, which is the speed of light that we can comprehend or we know. So when we see
The
light,
speed of light's faster than sound, right?
yes,
It's the fastest.
yes. I don't know much of the speed of sound either. I know about the speed of smell, but it's pretty slow some days.
Speaking of G-force, welcome to Turd Talks.
Yes. Welcome in. We were running over now. We're almost an hour and a half in, but
I knew it
it's
was
been
a
a good
Turd
talk.
Talk timer. That's
It
what
was.
It was, wasn't it? I knew
Yeah.
it. I knew it.
We're working on it. We'll have to save it. We'll save it for another day. We'll have to think of our next topic and let us know in chat or let us know through various be it Discord or be it different options. Let us know if anything you'd like us to talk about. Any final?
Hold on.
Yep.
I want my husband came into the room because he said it was a crazy story, and it's.
Okay.
I don't know if it'd be interesting whether we want to do it as a show or just if it sparks anyone's interest.
Okay.
What was you saying about there was a priest in the Vatican back in the day that what? Did you hear that?
I know I missed it. No.
He said there's a story about a priest in the Vatican back in the day that actually invented something where he could see time.
See time?
Yeah.
Okay.
But then, what is it covered up? Is that what you said?
Basically being covered up. It's hard to say. Like, it's hard to say, but I mean, I don't know. I don't know, but I definitely believe that, like there's somewhere, like there's like a starting point somewhere to what we are, and from that, the closer you get to it, time, the concept of time and how time necessarily exists or reality works in that time is completely different.
I feel like the older I get, time is speeding up. Like my days are shorter.
Yep.
Like we're about to hit
that.
Christmas again.
I feel that. I feel like once upon a time, like yeah, the seasons lasted longer and such. Yeah. And the days were, like I said, the days were longer. I remember when I lived on the other side of the country, and it's different when you're on the west. Like say the sun rises in the east, sets in the west, so it's a little different, I guess. But it would be late, like 11 o'clock, almost 11 o'clock at night, and the sun would just be going down, like twilight still. And I thought that was really weird because we don't really have that on the East Coast. I'd never seen that on the East Coast. So.
Well, I don't know. Do y'all do daylight savings time?
Yes. Yeah, we do that. Yeah.
That messes me up because whenever they do that, like it'll be pitch black outside at 5 o'clock.
Yeah. Yeah. At first, it ends up being like really trippy at first because it's like really dark, really early, and yeah, I know what you mean. But then that's just to save a little bit extra daylight because the times are going to switch flip flop kind of thing, right?
Right.
Or the times are like it would end up
being.
That
makes me want to look up the Alaska thing. Don't they go like 6 to 8 months in darkness or something?
There's a place where it's like 30 days of complete darkness. Yeah.
I wonder what causes that. That's what I'm gonna look up. Or do you know what it is?
Well, I'm not 100% sure, but I think it has something to do with the fact that we're not spinning like perfectly sideways. We're spinning kind of on an axis, like on an angle. So that would
So it's where they're located.
it has to do with location. So then in
That's what
theory,
TV just said.
yeah, theoretically there would be a counterpart to that in Antarctica as well, or somewhere else in the world. There'd be a counterpart to having that. Maybe they'd have um like pure sunlight for nothing but days. You know what I mean? Nothing but sun for how many days or something along those lines. I don't know exactly how that works, but it is a thing. I know that.
It's a thing. It's a thing.
It's a thing. So yeah, before we end, we got 7 people in here. Look at that. Awesome. That's wicked. Before we end, any
Don't forget to
final?
hit that like button.
Yes, always hit that like button for us. Always hit that like. And like I said, let us know. Let us know. Any final words of wisdom, Brittany? Instill on the people.
I just want to thank God for everything He's done and everything I know He will do. Time is getting shorter. Things are getting crazier, but the one thing that is constant is Jesus Christ. And if you know Him, you know how amazing He is. And if you don't know Him, get to know Him, because He's the way, the truth, and the life, and He loves you.
All right. God bless everyone. And this has been Turd Talks with Musty and Brittany.
Bye.